Hi, so we continue the Kosharayu strongly connected component algorithm implementation. I'm going to create a so-called depth first order class. It's going to make the depth first search basically. So we just create a private stack and it's going to store the vertices, of course. So it's going to have the name stack. And we will have a constructor. So in the depth first order, I would like to get a graph. I would like to instantiate this stack. So stack java.util.stack. Okay. I would like to iterate through all the vertices. So vertices v or vertex in the graph dot get vertex list. I would like to check that if that given vertex is not visited, then I would like to DFS on that given vertex. And of course we have to implement this depth first search. It is the same depth first search we have been discussing in one of the previous lectures. So we just set the vertex to be visited, set visited to be true. Okay, and we iterate through all the vertices. So we in the vertex.get adjacencies list, and of course we check that if that given vertex is not visited, then I would like to recurse and recursively call this depth first search method on that given vertex. So this is the typical depth first search. This is how we implemented it, and this is how we implement it now. And I'm going to create a helper method, public. It's going to return the stack, get reverse post order, and I would like to return this dot stack. Okay, and let's implement the Kosharayu algorithm itself. So Kosharayu algorithm. We are going to store a one-dimensional array of integers. These are going to be the IDs. So what does it mean? That for example, the ID with a given vertex index, this is why we have defined the index ID, sorry for that, the ID for the vertex. Because if we have a vertex, then the ID at that given vertex is going to be the ID of the strongly connected component containing that given v vertex. So these IDs are going to return basically the IDs for the strongly connected components. Okay, then we will have a count basically, because this is the number of the strongly connected components. We are going to assign integer numbers 0, 1, 2, 3 for the strongly connected components. Okay, and then we will have a private boolean marked, because we make two depth first searches. For the first depth first search, it's going to be fine that we use this boolean visited. But if we would like to reuse this visited boolean flag, we should iterate through all the vertices and reset the visited boolean variable to be false. I don't want to do that, because if there's lots of vertices in a graph, then it is quite expensive operation to iterate through all of these vertices. So that's why I'm going to create again a one-dimensional array of booleans to be able to check whether we have visited that given vertex or not. Okay, and in the Kosharayu algorithm constructor, we will get a graph. We instantiate the depth first order DFS is equal to a new depth first order, and we specify the transposed graph. Okay. Then the marked is going to be a new integer. The size will be the graph that get vertex list dot size. And we will have the IDs. Again, it's going to be a new one-dimensional array with the graph dot get vertex list dot size. Okay, so we just iterate through all the vertices, vertex, vertex, DFS get reverse post, we get the stack from the depth first order. As you can see, this is why we have defined it. So we get all that given vertices stored in a given stack, and we just have to check that if not marked where the vertex get ID, we just have to DFS on that given vertex, and we just have to increment the strongly connected components counter. Okay, what's the problem? Oh, sorry for that, of course it's going to be a boolean, not an integer. And we have to define this DFS. It's going to be the DFS again. We just have to marked, so the marked on that given vertex dot get ID, we set it to be true. So basically we set this vertex to be visited. We assign the strongly connected component ID, so the ID with the vertex get ID is equal to the counter, and we set the vertex dot set component ID to be equal to the counter as well. Okay, then we just iterate through the vertex get adjacencies list, and if we haven't visited that given vertex, then we are going to recurse on that given vertex, what means that we call this depth first search in a recursive manner. So this is how we implement the Koszar-Raju algorithm itself. In the next video we are going to test it. Thanks for watching.